8.2, description of an algorithm. So this is our last video of part A. So let's look at another different view, to understand algorithm. This time we describe, a few factors, from the different angle. All right. So we know our goal to use algorithms, find a solution for a computing problem. The next question is how to find a solution for a computing problem, right? So what is the basic procedure? Here, let me describe it in a general way. To find a solution, what do we need to do? We need a precisely defined procedure to get the answer. Here you can see this is important. Precisely defined procedure. So not vague, so very precise, very clear, no confusion. But still too abstract, right? So here, let me just give you a little more information, to make it more concrete. So we need to have step-by-step implementation details. Okay, and usually people use diagram, flowchart, to organize their thinking. So if the solution steps are pretty complicated, so then you may like to use, this kind of diagram, flowchart to help you organize your thinking. Okay. So each step you clearly describe, so what to do. But most of the time when the problem is not that complicated, so probably most people just, do not do this kind of thing, right? Because they feel they are very confident. So I can organize my thinking easily. So I do not need draw diagram, flowchart to organize my thinking. But you can imagine when the problem is very complicated, then you'd better use diagram to get your, whole algorithm idea well organized. All right. So each step can be represented in code. Then each small box, so one particular task can be translated into code implementation. So otherwise, if some particular task cannot be implemented by programming language, by the programming language of your choice, you get stuck, right? All right. So then you need to write your program. So after that, you need to write the program. So here you can see, we use IDE, so we write a program, and we do testing, keep modifying our algorithm details when necessary, right? So that kind of procedure. All right. So after that, then let's look at what is an algorithm from these concrete steps. From these concrete steps. So let's describe our algorithm another time. All right, first, we need to have a sequence of instructions. Programming language, coding instructions. Coding instructions. Okay. Java, Python, C++. Yeah. So for this class, the programming language, typically, the students use 3 different programming languages. Yeah. Okay. Java is 1. C, C++, another one. Then also, recently, more and more students use Python. Yeah. All pretty good choice. Okay. All pretty good. Yeah. All right. And your instruction should be unambiguous. So very clear. Yeah. Try to make it not too complicated. Yeah. Sometimes, some people write programming language statements in some very complicated way, because when you work as a team, development team, so you need to make sure your code can be easily understood by other members in your team. Yeah. All right. So try to, maintain your code in high quality, good quality. Yeah, let's say good quality. Yeah. All right. Then input. What kind of requirement you need to have for the input? Yeah. Input, the basic requirement, legitimate input. So your input should satisfy the condition based on the given problem. So usually your program need to, validate the input data. Yeah. So if it is satisfy the requirement, then you can work on the data processing. If the given data does not satisfy the requirement, then you should not do any processing, right? You should not do any processing because you may get something ridiculous, right? Yeah. So that's the requirement for the input. Next, the output. What's the requirement for the output? Yeah. The processing, after you process the data, you need to return the output with required format. The format based on your customers' needs, right? Your customers, because you solve a computing problem for your customers. Now, in a typical situation, you need to deliver a business solution for your customers, right? Now, then you should make the output follow your customer's requirement. Yeah. So here we use the required format. Yeah. All right. So then another factor important, execution time. Performance. How well your solution can provide to your customers, mainly a big measure, execution time. We need to look at that execution time. Is it fast enough or very slow? Yeah. So that requirement, first, finite amount. Finite amount, that is the minimum requirement, right? Minimum requirement. Not infinite amount, right? Definitely infinite amount, it's not acceptable. Yeah. So the minimum, the lowest requirement, at least finite amount. But most of the time, it is still, you need to do more than that, more than finite amount. So how much you need to do, yeah, acceptable to your users, your customers. Yeah. Your customers will tell you if the performance, if the response time, if the execution time is good enough. Okay? Yeah. Yeah. Because you may have the situation, your development team delivered a solution, and you feel we provide a pretty good performance, but your customers still not very happy, right? So that's reasonable. So they feel, we pay this much money, so we expect better performance than this one. Okay? So we want a better performance than this one. Okay? Yeah. So that happens frequently. Yeah. So you need to communicate with your customers. Yeah. If you can find a common ground, so what kind of performance is acceptable, right? So this issue pretty complicated. Yeah. Not just a finite amount, okay? And it's hard to say in certain number of time units. Certain number of time units. It's hard to say that, right? It depends on the complexity of the problems, right? Yeah. If the problem is very complicated, then the response time cannot be very fast. You need to spend a lot of time to find a solution. But if the computing problem is not that complicated, okay? So people have expectation, yeah. So they base on their, personal real world experience, they can set some reasonable response time goal for you, okay? But definitely for this issue, it's very complicated. Both sides, you need to communicate, yeah, to find agreement, yeah. Anyway, all right. So I want to stop at this point for our first part A, yeah. And from the next part B, so then we will learn the terminologies, the concepts, the method, thinking, all the details related to the algorithms. Okay? All right, so let me stop here. Yeah.